file, we create a new file, standard Jane code. We won't save this. We not save this, so we just create a new file. We just say standard G code, close this, create new standard J code. We have that. So we want to go to the file and copy the program text as example 3. Just copy that, into the software, and then we just paste it. Now we're trying to rebuild the program by selecting running. We just say rebuild. First we define our 2. Our 2 is a quarter of an inch, 2 number 2, and it is a slot mail, so we will just try and create that as a mail. We will just create it and add it to the database. Let's say it's a slot mail, and then if we have to get it from, let's just say add to the database, just say okay, then we assign that to that T2, and then we just say okay. We define our blank is so 541, and our region is 001, like that. We just say okay. Now we watch it, and we create the first arc down that way, and it's complete. Now if we want to trace it, just as we do all the time, the first line, it positions the 2 T0 the T2 at X0 Y0 Z1, and then it moves down to reposition the 2 now ready to cut. Then it does another feed down to Z0.25, and then it starts doing a real feed in the negative direction 0.25, and then the first J02 command will now move X 1.5 Y 1.5, then another move of X 2.5 Y 2.5 the radius 1, and then another move of X 3.5 Y 1.5 with that radius, and then another move of that to that radius, and then a linear movement to Y 1.5 up. The next movement is a counterclockwise J03 movement, so you see the direction of the 2 counterclockwise. Another move of J03, and that is also a counterclockwise move to Y 2.5 Y 3.5 X 2.5 Y 3.5. Another move which is an X 1.5 to Y 2.5. Another move that way, and then down, and the J00 takes the 2 up into the home position, and then the program ends. So that in the end also simulates the example number 3. Okay, so we want to move on to the next example, which is example number 4 from the slide. So as we move on, we look at example number 5. Basically, it's using a G02 and a G03 arc in the clockwise direction, trying to cut some full circles. Basically, this is the program. Let me just show you the image from here. The image from here is that we're going to create this is going to be an XZ plane. This is a YZ plane, So we're going to have a XZ plane, a YZ plane, and the top is an XY plane. So depending on which plane we are in, the gene command will change to either a gene 0, a gene 17, or a gene 18, or gene 19 to show the plane that we are working on. So this is just to show you that we're going to look at the program very shortly. So if you look at the program line, we have the workpiece. The tool number is tool number 4. We are using the slot mill. And then we have the tool start position. It's going to be X0, Y0, and then Z1 relative to the workpiece. When you use this, it means that it is starting up the top part of the workpiece. Then we have program number 1004. Just a quick edit of this slide. Quickly, this is not supposed to be part of the program here. Okay, so program number 1004 and 5 will come this way. We just try to reduce the font of this, and then okay, get it in position. Okay, so we look at that the same way we introduce absolute programming at Gen 20. We change the 2 M06 to 2 number 4, M03, spindle speed clockwise at a speed 1200. Give a rapid movement to position it to Z 0.25. Now you give a Gen 01 to feed to Z0, and then you give a Gen 02 to actually turn the block in a Gen 18. A Gen 18 is an XZ plane, so on the side view of the work. So this is basically what we're going to see. We're going to turn this block this way in the Gen 18 plane, and then we're giving a Gen 02. So we're going to do a clockwise movement. If you know, in that ZX plane, a Gen 02 actually behaves as if it's a counterclockwise movement. Then you have a Gen 03 command here, which is showing that we are also doing a counterclockwise in the Y and a Z plane. So you see that in the Y XZ plane we have the center coordinates is I and then K, and then in the YZ plane the center coordinate is J and then the K, and then in the we come back to the XZ plane again, and then you have a J and a K, and then we move to the J19 again to the YZ plane, and you have a Z and then a J and a K. Then you come back, and I just want to show you, come to the J17 plane, and then you have a J02 which is showing an I and a J, which is the XY plane. So I'm going to use a simulation to really run through this example for you to appreciate how this is created. So let's go to the example and show that we create a new file, the G code. So we will just pick the text file for the program example number 4, and we just copy that. Okay, so we try to rebuild this program, and then that is running. Rebuild. We've not defined a tool. It's a slot mill of size 0.5, so we change that 0.5, and the tool ID is tool number 4, and it's actually a slot mill, so we keep this, and then we just say OK, and then we do a tool selection. The tool command do a tool selection to T4, and then we say yes, and then we click on OK, and then we have to define the blank or the block, so we say yes. Now the block is supposed to be X4 Y4, and then we have the workpiece as 4 4 and then 2. Okay, the origin starts with 0 0 and then 2, then we click OK. So we watch it, then you see the movement down, and then it comes to the Z plane and creates that. Okay, so now let's do a quick trace of this program. We trace forward X. Now this is the position of the tool. Tool starts X0, Y0, Z1 relative to the workpiece. You see where it has positioned the axis. So X, Y, Z is that. Now we move on to the next trace forward. It now moved down to G00, Z 0.25. Okay, now it's not still cutting, it does a feed down, next trace, and it's moving down a G01 Z0 right on top of the workpiece. Now let's look at the next feed move, and the next feed move is showing a G18. A G18 means it's moving to a different plane, which is going to go to a G18, which is the XZ plane, and is doing a G02 X4 Z0. So it's moving all the way counterclockwise back to this point, and it is having the center of the center of the arc is Z0. I is 2, because when you look at the center of the arc will be somewhere here, and it's halfway, but the Z hasn't changed. So K will be 0 and then I will be 2. Then it does another G03 on this side, but it is the YZ plane. So it's a G19 command coming, and then that command comes, and then you have an X, a Y4 up there, and then you have a Z0J2 at the center. Then you have another XZ plane at the top here. So that's one, if you trace forward, it does it with the coordinates values shown there. And then finally another YZ plane at the side. It does it, and it comes into position. Now you do another trace right up to this position, another trace from that position 0.025, it moves to X1 Y2, and then another trace, it does a feed down minus 0.25, and another trace, it does a circular movement back to its position, a G02 and it used I1 and J0, but you did change the plane to J17, showing the exact plane that it is working at a speed of 10 inches per minute. So a J02, now this J02 that was given, there was no coordinate given, but when you do that, it means it is assigned to the previous coordinate. So it is do a J0 clockwise and come back to the same position, so it creates a complete circle for you. And then the next, it rapids up Z1 back to the home position, and then the program ends. So that is showing you an example of also how to use this J02, J03 in the various planes. Okay, so that ends the example 4. We're going to look at example 5 very shortly in our next slide. So we look at example 5 very shortly. So that ends at example 4. So now let's look at example 5. Now on example 5, we have to drill this set of holes. Now we have to drill, if you count the holes, there are 1, 2, 3, 4, and then 3 up here, so it's 12 3 by 4 holes that have been made in this blank, and we have to drill these holes. So our task is really to create the program to be able to drill these holes and complete all these 12 holes. So first we are going to look at it from just a raw sense of programming, where we command the tool to create this hole one after the other. Okay, so we want to look at this example 5, and in this example we want to drill these 12 holes using the CNC milling program commands with the J9 codes. So let's see how we simulate these holes. Just as we've gone through the previous programs, I'm just going to do a quick run through this. This is the workpiece. Then we put our drill size in there. Then we position our tool. Then we first initialize our absolute coordinates and then inch programming. There are two numbers, to number 7, so we give a 2 change command to 2 number 7. We turn the spindle on at a speed of 1000 RPM. Then we give a rapid go command to position the 2 at X1 and Y1, and then we give it a Z0.25 just to bring the 2 closer to the work surface. And then we issue a J98 command, which is simply repositioning the work coordinates as is, but this is not so important, a relevant command. It's just a program setting. And we give a J81, which is a cycle command. That's a drilling cycle. You give it a J81 command. X1 Y1 at the feed of 0.25. The retract plane, the tool will move back to up 0.25 at the feed rate of 3 inches per minute. So the tool will be creating, will be cutting through this. We'll just do a drill to this depth and retract to 0.25 at the feed rate of 3 inches per minute. Then it moves to Y2 up and do this drilling here, and then it moves to Y3 and do the same drilling with the Gen81 command and move to x2. So it just be changing the coordinates and be doing the same Gen81 command, y2, y1, all the way through, so it completes all these 12. So you have 1 2 3 4 5 6 7 8 9 12 12 command lines which is being captured. And then the 2 moves home to the home position, that is completing the drilling, and then it goes to x0, y0, and then spindle of program end. So let's once again simulate this and see how this program will really run in the software. So first again we create a new file, the standard Gen code, then we don't save this. We then go to our text file to copy our program. It's example number 5. We have example 5. We just copy the whole program and we open it in Notepad, copy that, come to the program and then paste it. So once we paste it, then we try to rebuild the program. We will rebuild it. It doesn't find the 2, so we do the 2 change to 2 number 7, to the 2 ID 7, and it's an HSS drill. So we just put HSS drill, right, and it's a drill, so we select drill, and then we give it the diameter. The diameter of that drill is 3/8 of an inch, which is 0.375, and we just maintain the height and then this angle. Then we just OK it, and then our blank size, we want to define it as x541, and this is 0 0, and this is going to be 1, and then we OK it, and we can watch the process as it creates the holes using the command Gen81. Okay, so it's basically drilled all these 12 holes. Now if we want to trace this program, we can do that. We trace forward. Here's the 2 start position relative to the workpiece, and then we move on to the first rapid movement to position x1, y1, and then it feeds down further 0.25, but it's not cutting. Then it comes to a Gen98 command, which is to feed at a depth of minus 0.25 and then retract back to 0.25 height. So we do a trace, and then it feeds and then retracts. This is the feeding, and then it will retract back in the same command, 0.25. Then the next is it move on to y2 and apply the same Gen81 command, but this time the y is 2, so x1 y2, and then it feeds down and retracts 0.25. Move on to the next command, y3. It does the same movement, feeds down and retracts. It does this next one, x2. It does the same movement, feed down, retract. Move on the next y2. It does the same movement, move down, retract. So it follows that way until it simply completes everything down there as the 12 holes are being drilled. So this basically will give you the simulation of the 12 holes. So this is just programming by not using any subroutine, or just a direct program. By writing your coordinates line by line, you will generate that. Okay, so this view was basically showing you what we finally generated here. Okay, so we move on to the next example, which is example number 6, which is actually programmed using incremental with a dual and then incremental coordinates. So if you are using an incremental coordinate system, we'll be programming using a J91. So we'll come to that, but first let's try to do a small editing here to the command line, like that. Okay. Okay, so now we want to look at this particular exercise here. So we're going to drill these 9 holes more or less, but we are using relative coordinates. So the next coordinate will be measured from the previous coordinate. That is what relative coordinate is. So if you watch this program, or if we try to run through this program, it's essentially like similar to the one that we did. It's just that, okay, we initialize this movement. First we initialize absolute coordinates. We change the 2 to 2 number 8. We give the speed, and we move a rapid movement x1 y1. We do a feed x z 0.25 to just get closer to the workpiece. Then we issue a J91. This time it means we have moved to a J91, which is relative coordinates, and then that is a J82 z minus 0.5, and the retract is 0.25. Okay, so we are moving z down minus 0.25 on this same point P1, but now any coordinate that we are going to give out now is relative to this coordinate 1 1. So if we give x1 relative to this, it means it is x2. If we give x2 relative to this one, it means it is what? X3. If we give y1 relative to this, is y2. If we give another y1 relative to this one, then it is going to give us a y3. Okay, and then we follow through with the rest. X minus 2, meaning that if x is 3 and it's come to minus 2, it means it moves to x1. Or if x is 4 and it comes to minus 2, it means it's x equals, it means it's 1. So now let's try to simulate this program and see how it will work with the software. So we go back to the software, we create a new standard program. We just copy the folder, the file, that is this time example 6. We copy example 6 into that, and then we paste it this way. Okay, now we try to rebuild this program. So we go to run rebuild. We define our tool. Our tool is tool number 8. So an HSS reel is 3/4 of an inch size over 2. So it's going to be 0.75. And then we OK it. It's basically working because the block and every other thing was defined, but I'll just show you the simulation afterwards when we do a trace of the program. Okay, so now when you look at this, if we want to trace it, we look at the program as it runs. First, the tool will be positioned at the start. The next is to give it a rapid movement, Gen00 x1 y1. The next is a feed 0.25, just about touching the work, and then a J98 command, which is showing this Gen00 command here. Now if we put a J91 command, then perhaps we change the values here, but it didn't program with the incremental coordinates, so we can leave these commands here as they have been written as the actual absolute command. So the next trace is trace forward, it does a retract back, it does a move to the next position, it does a retract, it does a move to the next position, it does a retract, it does a move to the next position, it does a retract, it does a move to the next position, it does a retract, it does a move to this position, and it does a retract, and all that. So it does that, and finally creates this as we see. Okay, and then it gets to the starting position. But we can do another simulation by just copying this program here into the main program and simulate it as it was meant to be. So you do that as I just copy that and show the Gen command. Okay, so let's try to rebuild this program. Tool number 8, we say okay. Let's define the block. It's 541. In the tool start position, this is 1 0 0, and just say okay. So now we can see. Okay, now because of our relative positions, we could not experience this program running to actually give us what we want. So we will just look at it as it was done earlier on, and move on to the next example, which is example 7, which we are going to find. We're going to see how that one is created. So we just move on to the next example. That is, we've done this, and so we look at the next example, which is looking at a programming example using this time we want to use a subroutine. Now the task is for us to create these 8 holes. Now these 8 set of holes are of the same depth, the same size. So instead of calling a drilling cycle, a Gen82 to drill each of them, we want to write a sub program to do the rest by calling a sub program to do the rest. So basically, let's just do a run to the program and then we will simulate for us to see how it works. Now, if you take this, we want to drill these 8 holes, but we are going to do it in 3 cycles. First, we want to do a spot drill. We want to do a center punch the hole, locate the center of the hole, and then first we use a smaller drill to go to this depth, and then we do use another drill to go to this depth, to drill with the same depth anyway. That is, we have 1/4 of an inch size drill, and then we do a 1/2 inch. So we start with a center punch 3/32 of an inch, which is going to be a smaller drill. Then we start a 1/4 of an inch drill and a 1/2 inch. Then we have the 2 start position, and we can then simulate the program. So first we give absolute coordinates, we change to select tool number 1, we turn the coolant on, and then we then give a rapid movement, Gen00 x1 y1, and then we give the Gen82 cycle, which is feed down minus 0.1, retract to the 0.1 plane with a pause of 0.5 of a second, because Gen82 is a drilling cycle with a pause. So pause for 0.5 seconds at a feed of 5 inches per minute. Then we call a subroutine. A subroutine call is an M98, and then the program number comes. So the P1005 is the program for the subroutine. That is the subroutine. From here, the program will skip everything and go to find program number 1005. So we go back down to find program 1005, and this is the program 1005 here. So the program will skip and come and execute this. So it does the first drilling over there, and then move to X2. Now this is X1, this is S2, this is 2, 3, that's 4. Now that's Y1, Y2 position. So it will do this first and then move on to this next, that is the X2, and then move on to X3. Move on to X3, which is, this is X2 and X3 is that. Move on to X4, which is that, and move on to Y2. So at this position it will move to Y2, still using the Gen81 command earlier on. So it will still come and use this Gen82 command, and then use it to do that cycle and then complete. Now once that is complete to all the 8 holes, right down to X1, that is coming back to X1 here, then it's moved to the next command, which is M99, which tells him to return from the sub program to the main program. So it will return to where it's started, or it moved from. So it will move to the next command, which is a Gen80, which says it should cancel all CAN cycles, again 28 will return to the 2 to the reference position x1 y1. Then it will turn the coolant off. It will do a 2 change to take a second to number 2, and then it will do a J29 return from reference position. The spindle will now turn on at a speed of 1200 rpm. The coolant comes on, and then another cycle J83, another drilling cycle is initiated, which is going to be a drilling cycle, which is going to be a peck drilling cycle, where it will take its incremental depth of cut. So it will move to -1 finally as a depth, but it's going to take it at a rate, it will retract to this plane 0.1 after every peck of 0.1 of an inch. So it will do this 10 times before it can get to the depth, the full depth, at a feed of 5 inches per minute. Then once it does this peck here, or pecking, then an M98 command is issued again to the subprogram P1005. So the program will now move right down from here back to the subprogram and then pick out the coordinates and do the drilling using that command. And after it's done, it will return from the subprogram now to this line. Cancel all CAN cycles, return the 2 to reference position, turn the coolant off, change the 2 to a third 2, return from the reference position, turn the spindle on to 1000 rpm, and then turn the coolant back on, and then you start another peck drilling cycle to also a depth of -1, but also you take it in 0.1 inches in it every time. So in 10 pecks you are able to get to the one depth here. And once you do that, you also want to call a subroutine, the same subroutine. So then the 2 then moves back to pick up these coordinate points to generate the drilling again. And then finally, one is complete, an M99 command will then bring the program to this point. It does a J00 and then continues right to the end here, and that ends the program at this point. So let's do a quick simulation for you to appreciate that. Okay, so I'm going to do a quick simulation. This is the last bit that we are doing, and then we will look at the assignment, and then that'll be it. So let's quickly do the simulation here. I'll just copy it into the program. Okay, so that's the program. We just rebuild it. Now we're going to define the tools, so it's very important we do that. So the first one is tool number 1. Okay, the tool number 1 is a spot drill. So spot drill. Okay, and then the size is 3/32 of an inch. That's 0.09375. 0.09375. and then we okay that. Now let's define our stock is 551.001. Okay, and now we just have to observe how the tool works. The remaining tools should have been defined, but the program has picked it, so it's vacant. But we could have defined all the remaining tools, but because the file is saved. But you notice that it first used a smaller tool to create the cycles, and now it's using a bigger tool to create the next, and it's doing that specking 10 times to actually generate the whole, because the Q is 0.1 and the Z is -1. So you notice that it's generated the first one. It will go ahead and generate the second one. I just want to pause this and improve the speed a little bit so that it can go slightly quicker than we are seeing here. Okay, so it will generate that. Move on to the next, and then generate that. So it does that finally, and then it creates the part. It's basically drilling with the second tool, which, so it does the Y2. Yeah. Okay, so you see that it is taking it in 10 steps. So it is taking it peck after peck in 10 steps to be able to finally generate that for you. Okay, and then it changes to a new tool which is bigger, and it is also taking it peck after peck to finally generate that tool for the diameter for you. So that is basically showing how we can use the SAP program, because we are going through the same number of holes, but we are using 3 different tools to do that, and that is why we need to write a SAP program to initiate that. Okay, so basically you could see how the movement is. So let's see how it completes these 3 holes, and then we could be basically done. Okay, so we can clearly see this movement of the tool. Okay, it does that in 10 pecks. So it goes up and down, retract to the plane in a number of steps, that is 10, to create the -1. Okay, right, so then it's ends the program. So it's done that using the subroutine called the sub program to do that. Okay, so that is what we show here in display, and that's how you can use it to write your coordinate points to create the program. So finally, we've been able to simulate some of these programs. Now I want to give you this assignment, and the assignment is this drawing you have in view. you are to write a program to create this drawing, this figure. These holes are countable holes, so they have a bigger diameter and a smaller diameter in there. So this is the question. The question, I'm just going to give it a read. It shows that the part is to be machined with a milling center, and you have a semicircular slot and all that. You are supposed to use an end mill of 0.5 inches in diameter as T01. This is the 2 number in 2 linear feed steps, each at a depth of 0.25. So you're going 0.25, 0.25 2 times, and then you create the depth. And then you have to use you drill a countable holes in 3 steps. First, you do a center drill, which is used to locate the centers. So you have a T02, and then you have another 2 T03, which you use to drill the 10 hole. You drill the holes in 10 canned cycles. When you say canned cycles, so you have to drill that holes in 10 steps. Okay, now you have finally an HSS drill, which is a bigger one, that will be used to create a countable to the depth of 0.5 of an inch, and then that's in 5 can cycles, and the retract plane is Z0.1. Okay, so that is the question, and I want you to write the program, simulate it, and save the code for submission. Okay, so thank you very much for staying up with me, and I hope you review the videos, and then we shall discuss with some feedback when we meet online. So thank you and have a good night.